if the discriminant value is greater than 0, then you know when you solve this thing, your roots are going to be real numbers and they are not going to be equal to one another. So they can't be the same. If the value you get for the discriminant is 0, you find that you do have roots that are real and equal, aka double root. We're going to go into this a little further. D, if the discriminant value is less than 0, aka a negative number, you're going to find that the roots are going to be imaginary conjugates. Okay, so inherently these numbers are positive. Of course, these are 0. These are negative, the values you get for the discriminant. Okay? Now, what does the discriminant allow us to find out? Well, if you look at example 1, they give us several samples. The first one, A, they say x squared plus 6x minus 2 is 0. Well, what do I know about the roots? Well, if I square my b value and then subtract 4ac from it, I can tell you something about what my roots should be. 36 minus 4 times 1 times negative 2 will give me my discriminant. 36, negative 4 times 1 is a negative 4. Negative 4 times negative 2 is a positive 8. I should get a 44 as my value. If the discriminant is positive, that means I have real unequal roots. And if I go in and solve it, and they do that for you there, I find out that the roots are both real and they do not equal one another. Okay? And they've solved it there using the quadratic formula. B, 3x squared minus 4 radical 3x plus 4. This is B. What do we know about the roots? Well, I'll tell you something about the roots. If I plug in my values, b squared, so negative 4 radical 3 squared, which is going to be 16 times 3, right? Minus 4 times a times c. So 16 times 3 is 48. Negative 4 times negative 3 is a negative 12. Negative 12 times 4 is a negative 48. My discriminant is 0. If my discriminant is 0, then I should have 2 real roots. Okay, a double root situation. By quickly doing the discriminant, I know it doesn't feel quick to you, but if you use this enough, it will. By determining this information, when I later go in and perform the quadratic equation on this, and if I came up with 2 unequal roots, I would say, well, either I did my discriminant wrong, or I've done my quadratic formula wrong. Okay, this is a good way to catch whether you're doing something wrong or not. C, x squared minus 6x plus 10 equals 0. What do I know about these roots? Well, I'll tell you something about these roots. If I get the discriminant, 36 minus 4 times 1 times 10, looks like it's 36 minus 40. Negative 4, it's a negative number. A negative discriminant tells me my roots are imaginary conjugates. And look, when they actually performed it, they did find 2 roots that were imaginary, including an I, that means, and they were conjugate to one another. Okay? 3 plus I, 3 minus I. Again, this is useful for double checking yourself. Okay, look at the top of page 318, 318. This summarizes what I just shared with you here at the top. If the discriminant is greater than 0, you have 2 roots that are unequal. If the discriminant equals 0, you have roots that are real, but it's a double root, so it's the same thing twice. And finally, if you have a negative number as your discriminant, that means the roots are going to be imaginary conjugate to one another. Okay? Example 2 puts this to the test without proving it to you by doing the quadratic. Example 2, it's the same thing what we've been doing. Without solving each equation, determine the nature of its roots. Are the roots imaginary conjugates? Are the roots real, unequal? Are they unequal and real? Are the roots double root? That kind of stuff. That's what we're looking for. So let's look at the discriminant for the first one and figure out what it is. B squared minus 4AC is the discriminant. So 49 minus 4 times 3 times 5. 49 minus, is that 60? Came up with a negative number, didn't I? Based on the rules above, negative numbers means I am going to have 2 imaginary conjugate roots. 2 imaginary conjugate roots. Why? Because the nature of the discriminant tells us that. Letter B. 2x squared minus 13x plus 15. Again, if you make a mistake, though, somewhere along the way, like I'm famous for doing, then you got to go in and redo it and find out where you made a mistake. What do I know about this? What kind of roots should this have once I plug it into my quadratic? Well, let's figure that out. Good grief. 13 squared. These big numbers are ample opportunities for mistakes. 169 minus 4 times 2 times 15. So, 4 times 2 times 15. 120. And you should have come up with a 49. Okay, 49 is positive. It's also a perfect square, which is kind of interesting. Positive. Positive numbers. Positive numbers have unequal roots. Okay? Unequal roots. And they're real numbers. They're not imaginary. Unlike negative numbers that have unequal roots that are imaginary. C. The nature of C's roots. It's just a little more complex when you're dealing with rational or radicals. B squared minus 4AC is the discriminant formula. So 2 radical 3x squared minus 4 times 1 times negative 1. So this is going to be a positive 4. 2 squared is 4. Radical 3x squared is 3x. 4 times 3x. Oops, x. Why did I include that x? Sorry. 2 squared is 4. Radical 3 squared is 3, so it's 12. Sorry about that. 16. 16. Real, unequal. Okay, just like the above. unequal. Real numbers, not imaginary. If you come up with imaginary when you do it, you did something wrong. Last one, D. Whenever you have situations where the big mess like this is in fraction form, find a way to multiply everything and get rid of the fractions. Clearing the fractions is going to be your best bet. If you multiply this entire scenario by 4, you clear your fractions. And you end up with this. It's a whole lot easier to solve quadratics when they are in whole number form. And all we did was rename it. We didn't change anything. It's just like reducing a fraction or renaming it with a higher denominator. Okay, what is the nature of these roots? Well, I'll tell you the nature of these roots once I find out what the discriminant is. B squared, 100, minus 4 times 1 times 25. Looks like the answer is 0. 0, which means it's a rational double root. Really all I care about is it a double root? Is it unequal roots that are real? Like these two? Or is it two roots that are imaginary conjugate? Okay? That's what we care about. Look at the top of the next page. Top of page 319. The 3 methods for solving quadratics. The first one you learned was factoring. You zero it out and factored. The second one you learned was completing the square. And the third one you learned was the quadratic formula. Which do you use when? Well, the quadratic formula is oftentimes usable when you need to find an answer quickly. Most calculators, you wouldn't believe that the higher end calculators will solve these for you and they will give you very good exact representations of numbers. Okay? Completing the square. So quadratics are great if you have a calculator. And if you need more exact answers, okay, like if it's going to be something odd, you need an exact number. But it can solve any quadratic, okay? Any quadratic can be used in the quadratic formula. The complete the square. The only reason I ever use the complete the square is when the b value is even. I never ever mess with completing the square unless the b value is even. Like something like this, x squared minus 5x equals 6. I can take half the coefficient of -5, square it, and add it to both sides, but it is not efficient. This I would not even bother with. I would either use a quadratic or see if it's factorable. Okay, so your b value must be even. Okay? Finally, about the discriminant. If the discriminant, b squared minus 4ac, results in a perfect square, you'd be better off simply factoring. Okay? So here's when you want to use what? Factoring is best when your discriminant results in a perfect square. Okay? Completing the square is awesome if your b value is even. Okay? When in doubt, pull your calculator out and use the quadratic. Okay? That should not say 1 through 31. That should say 1 through 29. 1 through 29.